friends! In this lesson, we are going to learn how to basically solve for a function, f(x), and identify the domain and range of the function. Let's get started with the opening exercise. We have 4 different representations of a function below. So we have, this is a table representation here, and then we have the actual function where the domain is here and it corresponds to the range that is within the brackets. And what's important here is that it gives us the actual explicit formula. So this is 2 to the power of x. So in this case, the domain is what your exponent is going to be. And then we have a diagram of this relationship as well as a sequence. And so the question is, how are the representations alike and how are they different? They are alike because they all sort of match the same pair of numbers, right? So we have a 1, just going to label this x and f of x. So we have a 1 that matches up to the 2, 0 that matches up to the 1, a 1 that matches up to the 2, 2 to the 4, 3 to the 8, and so on. And that is the same situation that we have on the function side, where the 0 matches to the 1, 1 matches to the 2, 2 to the 4, and so on, right? And they're the same values. And the same thing happens when you have a diagram, and that is already mapped out for you. And on the sequence, we have this right here that tells us that n is basically greater than 0, which means we are dealing with positive numbers. But then it also tells us that it's less than or equal to 4. So we are looking at basically 1, 2, 3, and 4. And then one thing to note in here, this is less than or equal to. So that means that we are including that 0 and we are including that 4. Now, however, the sequence, we are not including a 5. So that would be the difference that I see with the sequence, because my other representations here do include the 5 in the domain. So if I were to plug in for 2 of A, then that would generate a different correspondence. And so that's what makes them different. In this lesson, as I mentioned before, we are going to learn how to solve for f of x or f of n or a function and look at the domain and range for each of those. So let's go ahead and look at exercise number 1. We have a domain that they give us, and that's expressed right here. Let x equal 0, 1, 2, 3, 4, 5, and they've written it for you in this table right here so that you can just fill in the table. It says complete the following table using the definition of f, and that means when they're telling you that x maps to y, that means that it is a function, and they're giving you this explicit formula where f of x is equal to 2 to the power of x. So now we have to figure out what all these values are. So f of 0, your answer will go right underneath a 0. We have 2 to the power of 0, that of course will be a 1. 2 to the power of 1 will be a 2. And I'm just going to go ahead and continue doing this. What is the range of f? So if you remember here, they give us the domain, and so our range is going to be equal to, I'm going to grab the values of y or f of x. 1, 2, 4, 8, 16, and 32. And that is basically how we evaluate and identify domain and range of a function. Let's see if you can do exercise number 2 on your own. In this exercise, our explicit function is x squared. Okay, so we had to figure out the table for f of x, and we have the values here that they give us for the domain. X is going to be equal to 0, 3, negative 2, square root of 3, negative 2.5, 2/3, a, and 3 plus a. We basically grab this domain from inside the parentheses because that's x. And so you can use that to write in a table. Normally we want to order our table, but you don't need to necessarily because we are not going to be graphing. 0 squared, of course, is going to be 0. 3 squared is going to be 9. Negative 2 squared is going to be 4. Square root of 3 squared is going to be 3. Negative 2.5 squared is going to be, let me grab my calculator here, so 6 1/4. And this is going to be 4/9. It's going to be a squared. And then again, 3 plus a is going to be 3 plus a squared. Now I want to go ahead and simplify that one a little bit. So let me go ahead and get some space and do it right here. We have 3 plus a squared, which means we have two 3 plus a's. And then I'm going to use my distributive property to go ahead and simplify this. That's going to give me a 9, a 3a, a 3a, and an a squared. So it's going to give me a 9 plus a 6a plus a squared. And that's what I'm going to write here. And I'm going to put my a squared first. There we go. And then my next and last question for this is, what is the range, right? So the range is basically all the y values here. And you would just say, oh, my range y is equal to, and you would just list those y values in the same order as your x values. 0, 9, 4, 3, 6 1/4, 4 9s, a squared, ooh, ran out of room, and then a squared plus 6a plus 9. So let's go back a little bit into when you first learned about the real number system here. So we have the real number system, and the real number system is made up of several different types of numbers. You first learned about whole numbers, and after whole numbers, you learned about integers. And so whole numbers are positive numbers, and then integers are negative numbers. And then you learned about rational numbers, and of course rational numbers are numbers that can be expressed as a fraction. Theoretically, all our numbers can be expressed as a fraction. However, if it's less than 1, it would not be a whole number, right? And then we also learned about irrational numbers, and irrational numbers are a small subset of numbers that cannot be expressed as a fraction. So you would have examples of irrational numbers would be like pi and square root of 2 and all those numbers that we don't really deal with a whole lot. They're asking what subset of the real numbers would the domain of this function represent. So let's look at this function. Let's look at the formula for this function. It's square root of x minus 2. When I look at this, I have x and f of x. Let's say my x is going to be 0. Well, I'm going to plug it in here and have 0 minus 2. Unfortunately, that's going to give me a square root of negative 2. And that, my friends, is nowhere in the real number system. This is actually outside of the real number system. So that would not work. And so that is probably the reason that they are asking for you to think about all this. If I were, however, to give it a 1, it would not change much because it would be a negative 1. If I did a 2, it would be a square root of 0, which is a 0. And if I did a 3, it would be 3 minus 2, which is a square root of 1. So from x equals 2 on up, that really could be a domain. So we can say the domain is that x is so x equals 2, and then it goes all the way up. So we use that. It's not an ordered pair. It's a notation that we usually use for domain and range. Now with that, our range, of course, when x equals 2 is going to be 0. So our range is going to be, and I'm not going to use y, I'm going to use f of x. 0, and it's going to go all the way up. So that's how we would write that particular example. Okay, so let's go ahead and review the few things that we have done here. We have learned how to identify the domain and range and solve for a f of x function. So we talked about what that would look like if it was x squared, and what 2 to the power of x would look like. We also talked about square root functions, and we in the past looked at triangular functions as well, so that's what they're talking about here. In the problem set, you're going to need to solve for these functions, and so essentially you're going to plug in the x for the value that is in between the parentheses there and evaluate the function for the given input. And then you will also be required to talk about what the range would be of each function. And so you can just say, well, the range is going to be, or in this case, y or f of x, you know, the smallest value, the smallest possible value that makes sense. And if it goes all the way up, then you use the symbol infinity. So that's sort of how you would do that.